Hi everyone, my name is Arnau Blanco, and in this video series I'm going to show you how to build a large language model completely from scratch. I've split the project across different videos so we can focus on one piece at a time, building the code step by step on top of the previous video until we have a working text generation model. Also, all the code from these videos will be available in a public GitHub repo linked in the description below. So the first question is, why build an LLM from scratch? Well, if you spend some time on social media or in the tech world, you've probably noticed that AI is absolutely everywhere. Companies are constantly launching new tools, automating tasks, or releasing new models every other week. But because the word AI gets thrown around so much, it's easy to lose track of what's actually happening under the hood. It becomes a bit of a black box. You see what these models can do, but it's not always clear how they are trained, how they process language, or what's actually going on inside the code. That's what inspired me to make this video series. By building one from scratch, you just don't figure out how they work, but you learn their actual limitations and you gain the intuition needed to tailor these models for specific real-world use cases. So what is a large language model? At its core, an LLM is a type of deep learning model. If you think of AI as the broad umbrella, machine learning sits inside it, and deep learning is a subfield focused entirely on artificial neural networks. Neural networks are mathematical models loosely inspired by the human brain. While they've been around for decades, it wasn't until the 2000s that researchers seriously began using them to process language. Then came 2012, a massive turning point for AI. Deep neural networks absolutely shatter records in image classification tasks. Seeing how powerful these networks were at understanding pixels, researchers quickly realized that they could adapt similar deep architectures to understand text, setting off a massive wave of innovation in language translation and processing. Then in 2017, researchers at Google changed everything. They introduced a transformer architecture in a paper titled "Attention is All You Need." We'll be breaking down how that architecture works conceptually in the upcoming videos, but what's important for now is that this paper directly inspired OpenAI to build GPT-1 just a year later in 2018. OpenAI realized that if they scaled this architecture up with massive data, it got exponentially smarter. To fund the millions of dollars needed for GPUs, OpenAI actually had to shift from a non-profit to a capped profit company, leading to the release of GPT-2 in 2019. Later on, in 2020, OpenAI scaled it even further and released GPT-3, fully documenting its exact architecture. Then came November 30, 2022, and everything changed overnight. OpenAI packaged their model into a simple conversational interface and released ChatGPT. It completely exploded, reaching 100 million users in just 2 months and redefining the entire tech industry. But that massive commercial success also marked a massive shift. While OpenAI openly shared the architecture details for GPT-3, they closed the curtains for everything that came after. With models like GPT-4, the exact internal architecture is hidden behind closed corporate doors. That is why for this video series we'll be building a GPT-3 style architecture, but not the latest one. The fundamental code and math powering the latest GPT models are the exact same thing as the GPT-3, but the way they are arranged is slightly different. GPT-3 is a monolithic model, meaning that when you give it a prompt, you activate the entire network to get a response. The latest models, however, use a mixture of experts architecture. That is, instead of one giant network, they have several specialized subnetworks inside of them, and a smart router only calls on the specific experts needed to handle the nature of your prompt. In the upcoming videos, we'll be using Python and PyTorch to code this entire architecture and its training pipeline from scratch. If you want to follow along, make sure you grab the code from the GitHub repo link in the description below, and I'll see you in the next one.